JWST finding the first stars in the universe?
What if the first stars didn't just light the universe, but rewrote everything we thought we knew? For billions of years, their existence was only theory, until now, something in deep space changed the story forever.
Our star, the Sun, has mostly hydrogen and helium, whose origins we trace to the Big Bang itself.
Right after the Big Bang, the universe didn't look like space as we know it. No stars, no galaxies, not even a single spark of light. Just this endless, cold ocean of hydrogen and helium, drifting in total darkness. Imagine that for a second, an entire universe with absolutely nothing to see. And for millions of years, nothing changed. It stayed quiet, still, almost like the universe was holding its breath. This phase is what scientists call the Dark Ages, but honestly, that name doesn't even do it justice. It wasn't just dark, it was empty, lifeless, and silent. But here's the strange part. Even in that silence, something was happening. You couldn't see it, you couldn't hear it, but gravity was slowly pulling everything together. Tiny clumps of gas started forming, then bigger ones. And inside those clumps, pressure began to rise. Now imagine being there, floating inside one of those collapsing clouds. Everything around you is getting tighter, hotter, denser. No light yet, but something is building, something big, and you wouldn't even know what's coming next. Because here's the real question. What finally broke this endless darkness? And more importantly, what could possibly create light in a universe that had never seen it before? As these clouds kept collapsing, the pressure didn't just increase. It reached a point where something completely new was about to happen. Something the universe had never done before, and this is where everything changes. Deep inside those collapsing clouds, the temperature shot up so high that atoms couldn't stay apart anymore. They fused. And just like that, the first stars were born. But these weren't normal stars, not even close. Scientists call them population 3 stars. And honestly, they were more like cosmic monsters than anything we see today, massive, blindingly hot, and completely different from our sun. Here's why. They were made from pure hydrogen and helium. No heavy elements, no carbon, no oxygen, nothing to cool them down. So instead of forming small, stable stars, they grew and grew and kept growing. We're talking about hundreds of stars, maybe even 1,000 times bigger than the sun. Just imagine that scale for a second. If our sun feels big, these things were on a completely different level. But here's the twist. They didn't last long, not even close. While our sun will live for billions of years, these giants burned through their fuel in just a few million. Fast, violent, unstable. And when they died, they didn't just fade away. They exploded. Massive supernova explosions that ripped them apart and scattered the very first heavy elements across the universe. Carbon, oxygen, iron, the stuff that would one day become planets. And even us. So yeah, these stars didn't just light the universe, they built it. But if they were this powerful, this bright, this important, why couldn't we see them for decades? Where did they go? And how do you even find something that existed over 13 billion years ago? Because to answer that, scientists needed something more than just a telescope. They needed a way to look back in time. And this is where things get really interesting, because the tool that changed everything isn't just a telescope. It's basically a time machine. The James Webb Space Telescope was built for one reason: to look deeper into the universe than anything before it. But here's the trick. When we look into space, we're not just seeing distance. We're seeing the past. Light takes time to travel. So when something is billions of light years away, we're seeing it as it was billions of years ago. Now imagine pushing that idea to the limit, looking so far back that you're watching the universe when it was just getting started. But there's a problem. The light from those first stars, it's not visible anymore. Over billions of years, the expansion of the universe stretched that light into infrared, completely invisible to our eyes. And that's exactly what Webb was designed to see. Its massive mirror and ultra-sensitive instruments can pick up the faintest, oldest signals in the universe, signals that have been traveling for over 13 billion years just to reach us. So when Webb finally turned its gaze to the early universe, everyone expected something big, but what it found wasn't what anyone was looking for. It didn't capture a clear image of the first stars. Instead, I found something stranger, something that shouldn't have been there. And the answer to that mystery starts in one of the oldest galaxies ever discovered.
Out of any family of stars just born, you can ask, well, how many stars of low mass are there? How many stars are of middle mass? How many stars are of high mass? Everywhere we've ever looked, there are many, many more low mass stars than high mass stars.
When the James Webb Space Telescope focused on GN-Z11, a galaxy from just 400 million years after the Big Bang, scientists expected something normal for that time. Young stars, early structure, nothing too strange, but then something showed up in its surroundings. Not inside the galaxy, but just outside it. A faint cloud, almost invisible. At first, it didn't seem like much, until they looked closer. This object, nicknamed Hebe, may be a pristine pocket of gas, exactly the kind of environment where population 3 stars could still form. And this is where it gets insane. The light from that cloud revealed something very specific: doubly ionized helium. That means the atoms had been blasted with extreme radiation, so powerful it stripped away both electrons. That kind of energy doesn't come from ordinary stars. But here's the part that made everyone pause. There was nothing else there. No oxygen, no carbon, no nitrogen, just helium and hydrogen. Completely pristine, like a piece of the universe that somehow escaped time itself. Now imagine being a scientist looking at that data. You're seeing a signal that shouldn't exist anymore. A chemical fingerprint from the very beginning, still untouched. Only extremely hot, massive stars can produce that kind of radiation. So what could create something like that? The leading idea: hidden population 3 stars. Not directly visible, but lighting up this gas cloud like ghosts in the dark. A signal with no heavy elements. Could this really be the first stars? Or is this just a clue, pointing to something even bigger we haven't seen yet? Because as shocking as this was, it wasn't the only thing Webb found. Somewhere even farther away, light from a faint object was bending through space, magnified by a massive galaxy cluster called MAX J0416. This natural lens amplified the signal nearly 100 times. And behind that lens, something appeared: LAP1b. At first glance, it looked like just another distant object, but when scientists analyzed its light, everything changed. Because this time, it wasn't just a strange signal. It looked like actual stars. And not just any stars. Ones with almost no heavy elements. Exactly what you'd expect from the first generation. The environment matched, too. A small, dark matter halo. The perfect birthplace for early stars. Everything lined up almost too perfectly. But here's the catch. Scientists aren't calling it confirmed. Not yet. The word they use is candidate, careful, cautious. Because in science, this kind of claim changes everything. Still, if this turns out to be real, it would be the first time we've ever seen these stars directly. But even this might not be the biggest surprise Webb has found, because something else out there is breaking the rules completely. Webb discovered Jade's GS-Z14 rewrote, a galaxy so far away we're seeing it just 290 million years after the Big Bang. That alone is crazy. But what's inside it? That's the real problem. It's too bright, too big, too evolved. And then they found oxygen. Think about that. Oxygen shouldn't be there yet. For it to exist, an entire generation of stars had to form, live, and explode before this moment. All in less than 100 million years. That's not just unexpected, that's impossible, at least based on everything we thought we knew. So now the question is, how did an entire generation of stars live and die so fast? Is our entire timeline of the early universe wrong? And if that wasn't strange enough, what if these weren't even normal stars to begin with? Because now, scientists are starting to consider something way more extreme. What if some of these early objects aren't stars at all? There's a theory about dark stars, not powered by fusion, but by dark matter. Imagine something massive, millions of times the sun, but cooler, puffier, almost unreal, burning not with fire, but with something we barely understand. And when these things collapse, they don't explode, they just fall inward, becoming massive black holes almost instantly. There's also the idea of direct collapse black holes. No star phase at all, just gas collapsing straight into darkness. Some of those strange, little red dots Webb keeps seeing, they might be this. What if the first stars weren't stars at all? Are we looking at something completely new? Something that breaks our current physics? Because all of this leads to something much deeper. Because at the end of all this isn't just about stars, it's about us. Those first stars, whatever they really were, created the first heavy elements. When they died, they scattered carbon, oxygen, and iron across the universe. Every atom that makes up your body started there. They ended the Dark Ages, cleared the cosmic fog, made the universe transparent, made galaxies possible, made life possible. So when we look at these discoveries, we're not just looking at distant space, we're looking at our own origin story. If we are made of these stars, what else don't we understand about where we come from? And as Webb keeps looking deeper, what else is waiting out there? Because the deeper we go, the stranger everything becomes. The first stars didn't just light up the universe, they built it. And somehow, after billions of years, we're only just starting to see their traces. That's the crazy part. So what do you think is really out there? Because this story, it's far from over.